Hello, welcome to next session. In this session, we'll solve grade 2015 Mechanical Engineering Paper 1. Question 1 to question 25 carry 1 mark each. Question number 1 is, if any two columns of a determinant P is equal to 439716852 are interchanged, which one of the following statements regarding the value of determinant is correct? Option A, absolute value remains unchanged but the sign will change. B, both absolute value and sign will change. C, absolute value will change but the sign will not change. D, both absolute value and sign will remain unchanged. So when any two row or any two columns are interchanged, then the absolute value of determinant remain unchanged, but the sign changes. Okay, so answer is A. You can check it. Okay, by interchanging rows or columns. Okay, so answer is A. Next, among the four normal distribution with probability density as shown below, which one has the lowest variance? Okay, these four curves are shown. Okay, so this is your curve one. This is your curve one. This is your curve one. This is your curve two. This is your curve three. This is your curve four. Okay, so you have to choose the curve having least variance. So option are one, two, three, and four. Okay, ABC. So this is the normal distribution curve. This is mean. This is your standard deviation, and variance is nothing but scale of standard deviation. So as the standard deviation is least for uh, fourth curve, so variance is also least for that curve. So answer is your D. Next, Simpson's one-third rule is used to integrate the function fx is equal to 3 by 5 x square plus 9 by 5 between x is equal to 0 and x is equal to 1 using the least number of equal subintervals. The value of the interval is, so this is your fx is your 3 by 5 x square plus 9 by 5. Okay. So according to Simpson's rule, uh, and for equal intervals, the least number of intervals should be two. For uh, for for equal intervals, at least there should be two intervals which will make them equal. Okay, so one cannot make itself equal. Okay, so there should be at least two intervals, and so the step size is your as total limit is your 0 and 1. Okay, so step size is your 1 minus 0 by 2, that is 0.5. So the first part is your x1 is equal to 0 and x1, x2 is equal to 0.5 and x3 is equal to 1. Okay, so now by performing integration, so del x by 3, according to Simpson rule, del x by 3 bracket fx1 plus 4x2 plus 4 plus fx3. Okay, so this is the formula. Now the fx is given as this is 3x square, 3 by 5 x square plus 9 by 5. If we put x 1 as 0, then we get 9 by 5. If we put x 2 as 0.5, then it is 3 by 5.5 square plus 9 by 5. If we put x as 1, then we get 3 by 5 plus 9 by 5. So solving this, we can find out answer as 2. So answer is your 2. Next, the limit, the value of limit x tends to 0, 1 minus x square divided by 2x4 is option A 0, option B 1 by 2, option C 1 by 4, option D undefined. So limit x tends to 0, 1 minus cos x square divided by 2x4. Okay. So if we put x equal to 0, then here it is 1, here it is 1, here it is 0. So it is 0 by 0 form. Okay. So 1 minus 1 by 0 is 0 by 0 form. So using a logical rule, so differentiating this and this above term and below term, and putting it equal to this. Okay. So this is the formula for L hospital rule. Okay. Limit x tend to 0, fx divided by gx is equal to limit x tend to 0, f dash x divided by g dash x. So fx is your 1 minus cos x here and gx is your 2x 4. Okay. So differentiating it is 0 and cos differentiation is sin x here into 2x. Okay. Divided by 8x cube. Okay. Now again putting uh, now again, if we put the limit, then it is you are again 0 by 0 form. Okay. So again using LF rule, so it will be differentiation of this differentiation of sin x square is cos x square into 2x and differentiation of 4x square is 8x. So putting x is equal to 0. This is 0. This is 1. Okay. And this will be 4. So answer is 1 by 4. Answer is C. Next. Given two complex numbers z1 is equal to 5 plus 5 root 3i and z2 is equal to 2 by root 3 2i. The argument z1 by z2 in degree is option A 0, option B 30, option C 60, option D 90. So z1 is your 5 plus 5 root 3i, okay, and z2 is just 2 by root 3 plus 2i, okay. So dividing these two, we get 5 plus 5 root 3i divided by 2 root 3 plus 2i, and this is your this this comes out as, if we solve this, okay, then it will be 5 by 2 root 3, okay. So for any complex number, the argument is 10 inverse of imaginary part where real part. So here the imaginary part is your 5 root 3 by 2 and the real part is x. Okay. So argument is 10 inverse 0 by 5 by root 3 2. So answer is 0 equals to 0. 10 inverse of 10 0 is inverse 10 inverse of 0 is 0. Answer is A. Okay, next. Consider fully drilled flow in a circular pipe with negligible interest length effects, assuming the mass flow rate, density, and friction factor to be constant. If the length of the pipe is doubled and diameter is halved, the head loss due to friction will increase by a factor of option A 4, option B 16, option C 32, and option D 64. So HF is given by this FLV scale D by 2D. Okay. Now, as the length has been doubled and diameter has been halved, okay, so we have to change this equation in terms of length and diameter. Okay, and this charge is constant. Okay, so F is friction vector below, and now velocity of fluid can be written as Q by pi by 4 d square. Okay, the Q is just flow rate, and so V can be changed. So V can be written as Q square divided by pi square 4 square. Okay, D pi D 4 and 1 D is here. Okay, so HF is uh, directly proportional to L and vertically proportional to D pi. So initially, sorry, when the initially it is length is L and diameter is D. Now the length has been doubled and diameter has been half. So the head loss is your HF1. So HF by HF1. So HF1 is equal to 64 HF. Its answer is 64. Next, Lassius equation related to boundary layer theory is a option A third order linear partial differential equation, B third order non-linear partial differential equation, C second order non-linear ordinary differential equation, D third order non-linear differential ordinary differential equation. Okay, so in the Blassius equation, it is derived by the Blassius. Okay. So a compressible fluid is flowing in at a two-dimensional flow. Incompressible flow is considered on a flat plate with zero angle of attack. Okay, and as the flow is incompressible, so rho is constant, and we assume that Viscosity is also constant and there is no pressure variation along x. Okay, so dp by dx is 0. Okay, so the continuity equation is given by curly e by curly x plus curly v by curly y is equal to 0 continuity, and energy equation is given by u curly e by curly x plus v curly e by curly y is equal to mu curly square u by curly y square. This is the energy equation. Okay. Now, in this equation, there are two independent variables that are x and y. Okay, so he transformed these two variables into zeta, psi and zeta. Okay, so he put psi is equal to x and zeta is equal to y root u infinity dx. Okay, so that xi is function of y and x and zeta is function of x. Okay, now as he has converted this uh, x and y to zeta and xi and zeta. Okay, so using chain rule, he he put a relation between their differential also. Okay, so here we have this we have we have assumed that zeta is equal to xi is equal to x and zeta is equal to this. Okay, so we have to convert this xi curly by curly x, curly by and curly square by curly y square also. Okay, so to convert this, he used chain rule. So curly by curly x is equal to curly by curly xi. Okay, curly xi by curly x plus curly by curly zeta and curly zeta by curly x. Okay, similarly for y also, curly by curly y and curly by curly zeta and curly zeta by curly y plus curly by curly zeta and curly zeta by curly y. Okay, so here we can see that curly xi by curly x is 1. Okay, so we can put 1 here, and curly xi zeta by curly x we can find out. Okay, so curly zeta by curly x we kept the same. Okay, now curly xi by curly y is 0. So the zeta is xi is not the function of y. So curly xi by curly y is 0. Okay, and curly zeta by curly y is your this factor only. Okay, so now he uh, found out this curly by curly x is equal to putting this curly xi by curly x is 1. Okay, so curly by curly xi plus curly zeta by curly x and curly by curly zeta. Okay, and again curly by curly y, now this factor is 0. This factor is 0. Okay, so putting it equal to 0, only these things are left. This is equal to this. Okay, so curly by is your curly root u infinity bx curly by curly x. Okay, so and again differentiating, so this quantity is independent of y. So uh, this quantity is again differentiating. We have this curly square by curly zeta square. Okay, and curly by curly zeta square. Okay, again differentiating. Okay, because curly will put again curly xi by curly y, and curly xi by curly y is this quantity, so it will the scale root will be cancelled out. Okay, so now we have curly by curly x, curly by curly y, curly square by curly y square. Okay, now we have to put this u this u and v also. Okay, so finding out this u and v. Now he also defined the steam function as root mu x u infinity function of zeta. Okay, so now this u we know that it is curly xi by curly y, and curly xi by curly y is nothing but curly curly pi by curly psi by curly y is nothing but curly psi uh, by curly zeta and curly zeta by curly y, and curly zeta by curly y is this quantity, this curly zeta by curly y, this quantity. Okay, so this can be written as curly zeta by curly y and curly psi by curly y. Okay, so this is your curly zeta by curly y, and this is your uh, this curly xi by curly zeta is can be found from this. Okay, this will be, then this will be f dash, and uh, this will be f dash, and other quantity will be bx u infinity, and root u b sorry root mu x in u infinity, and mu x root will cancel out, so u infinity will be left. Okay, so u is your u infinity f dash zeta. Okay, and similarly we can also find out that is curly by curly x. Okay, and curly by curly x is putting putting xi here. Okay, putting xi here. Okay, previously we put zeta here. Okay, so putting xi here, sorry, putting psi here. So this will be this quantity, and curly uh, pi psi by curly xi is curly pi by curly psi, and this curly xi by curly x, this is curly psi by. So curly psi by curly xi is your curly psi by curly psi, and this is curly psi by curly x, and this is curly. This is your curly psi by curly x is curly psi by curly x we have found. Now curly psi by curly x is your uh, curly psi by curly zeta is your u infinity mu root x 1 by 2, and f. Okay, curly psi by, okay, we differentiate it. Okay, and then we differentiate it with respect to x, and then curly psi by curly x is your 1. Okay, so it will be this. Okay, and curly zeta by curly x is your bx uh, bx u infinity root. Okay, and this is your curly psi by curly x. Okay, this will be f dash. Curly psi by curly psi is this quantity. Okay, curly psi by. Okay, so now if we put it in this equation, we can have and solving this equation, we can have this as third order non-linear ordinary differential equation. Okay, so you can now solve this. Okay, take it now, substituting into, this is your 2, this is your 2. Okay, and we have this curly xi by curly x, and u, okay, and v. Okay, xi is this quantity. Okay, curly xi by curly x can be, that is used. Okay, and curly xi by curly psi zeta is curly xi by curly zeta is this from this equation. Okay, so this comes out as this. Okay, so now putting this in the equation number 2, all the quantities we get third order non-linear differential, ordinary differential equation. Okay, next, the flow of viscous fluid over a flat plate if the fluid temperature is same as the plate temperature, the thermal boundary layer is option A thinner than velocity boundary layer, B thicker than the velocity boundary layer, of the same thickness as the velocity boundary layer, not formed at all. So as the plate temperature and the fluid temperature is same, so the thermal boundary layer will not be formed at all. Okay, so answer is B. Next, for an ideal gas with constant value of specific heat for calculation of specific enthalpy, it is difficult to know, option A, it is difficult to know only the temperature. Both temperature and pressure are required to be known. C. Both uh, temperature and volume are required to be known. D. Both temperature and mass are required to be known. Okay. Uh, if for an elements, this conference can be specific to calculation of specific enthalpy. The specific enthalpy is given by CPT1. Okay. So it is sufficient to know the temperature only. Okay. Only temperature is known, then we can find out the specific enthalpy. Okay. So answer is next. A Carnot engine CE1 works between two temperature reservoir A and B, where TA is equal to 900 Kelvin and TB is equal to 500 Kelvin. A second Carnot engine CE2 works between temperature reservoir B and C, where TC is equal to 300 Kelvin. In each cycle of CE1 and CE2, all the heat rejected by CE1 to reservoir B is used by CE2. For one cycle of operation, if net Q absorbed by CE1 from the reservoir A is 150 megajoule, the net heat rejected to reservoir by CE2 in megajoule is. So this is a diagram given. PA is 900, this is QA, this is QB, this is work done. Okay, and this is your TB 500, this is QB. Okay, and to maintain its temperature movement, the QB that is receiving is rejecting. Okay, so WBC then with QC. Okay, that's just a bit QC. Okay, as both cycles are Carnot cycle. Okay, so QA by TA is equal to QB by TA is equal to QC by TA. Okay, as they are reversible processes. Okay, so QA is 150 and TA is 900. Okay, so QA is 150 and okay, so we can find out QC. TC is also given. Okay, we can find out TC. Oh, sorry, QC. QC is your QC is your 50 megajoule. Okay. Okay. So this is simple Carnot cycle question. Okay, we have to keep this classes inequality classes sure okay, member. Okay. Next, air enters a diesel cycle with a density of 1 kilogram per meter cube. The compression ratio is 21. At steady state, the air intake is 30 into 10 power minus 3 kilojoule per second, and the net work output is 15 kilowatt. The mean effective pressure is in kPa is so. First of all, we may find out the work done, and then we divide it by swept volume. Then this is the mean effective pressure. Okay. So let us find out the work done. Density is 1 kilogram per meter cube, and compression ratio is 21. And mass of intake air is this 30 to 10 to minus 3. Okay, and net work output is your 15. So net work output is given. Okay, so now it is more easy to find out this okay mean effective pressure. So we'll find out the volume at NTS, mass at NTS is your 13 to 10 to minus 3 kilogram per second, and compression ratio is 21. So volume after compression is your uh, V2, that is uh, and to 21st of this. Okay, we divide by 21, that is compression ratio. We get V2. So now swept volume is your V1 minus V2. Okay, so this is your swept volume. Okay, now this is work output. Okay. Okay, first of all, we find out this volume because mass is given, density is given. Okay, so this is your work output, and work output nothing but mean effective pressure into swept volume we have found out. So now P mean effective pressure is your 525 APA. So we'll solve remaining question in next video. Okay, thank you very much.